In the past, the advice was often to avoid using JavaScript in QML. While there is still a valid argument for using C++ instead of JavaScript for performance reasons, advancements in QML compiler tools have changed the landscape. Today, much of the JavaScript written in QML can be compiled directly to C++, achieving near-native performance. The decision now is more about style and convenience, though writing well-structured QML and JavaScript remains crucial. For optimal performance, it's true that intensive computations and multi-threading should be handled in C++. However, the focus has shifted to separating the concerns of the backend and the UI. QML offers numerous ways to integrate with C++, and much of the Qt framework is designed primarily for C++ usage. Therefore, it's important to structure your application so that QML and C++ each play to their strengths. Should you completely avoid JavaScript in QML? Not necessarily. There are situations where using JavaScript is both practical and convenient. However, since JavaScript is not perfectly type-safe, it requires careful usage. Like seasoning and cooking, JavaScript should be used sparingly and thoughtfully. This section provides specific tips for effectively using JavaScript in QML. Use type annotations on functions. Since Qt 5.15, QML supports type annotations similar to TypeScript, allowing JavaScript functions in QML to be type-safe. By adding type annotations to function parameters and return values, you not only improve code auto-completion, but also enable the compiler to convert more of your code to C++ for enhanced performance. Without type annotations, functions are compiled as bytecode and processed by the just-in-time JIT compiler, leading to variable performance. To demonstrate the usefulness of type annotations, let's start with a simple example. Add an item and define the following function. Next, create two properties that call this function. In the component onCompleted handler, log the results. In this example, the first call passes integers, so a plus b results in 30 as an integer value. The second call passes strings, so a plus b performs string concatenation, resulting in 30. The behavior of the function changes based on the input types, which can be subtle and may lead to unintended results. To ensure that the function only accepts specific types and returns a defined type, we can use type annotations. Let's update the function to specify the types for the parameters and the return type as int. Functions that do not return any value do not need an annotation for the return type, as void is assumed. Since JavaScript in QML does not support function overloading, a separate function is needed for strings. Update the properties to call these two functions. Log the results again. Run the code to see the output. The functions are now unambiguous and type-safe, allowing the compiler to translate them efficiently into C++ code. Remember, only QML value types or QML object types can be used in JavaScript type annotations. Type annotations are not needed in signal handlers because the types of the arguments are inferred from the signal itself. Use let instead of var inside JavaScript blocks. Using let to declare variables in JavaScript provides precise control over the scope of the variable within functions and nested code blocks. Variables declared with var have a function-wide scope, while let variables are limited to the immediate code block in which they are defined. A var variable is initialized to undefined and accessible anywhere within the function, even before its declaration. Its value updates to the assigned value once the line of declaration is executed. However, using a var before it is properly assigned will return undefined. In contrast, let variables are not initialized until the line where they are declared is executed. Attempting to access a let variable before it is initialized results in a reference error. To see the practical difference, add an item with a function called varFunction. Inside this function, add a for loop. Next, log the values of index and internal outside of the for loop. Call the function in the component onCompleted handler. Run the code and observe that both index and internal are accessible outside the loop scope. They have been hoisted to the function scope, but before the for loop, their values are initialized to undefined. Now let's see the difference with let. Copy the entire var function and rename it let function. Change all var declarations to let, and call let function in the component.onCompleted handler. Run the code again, and you will see that accessing index and internal outside of the for loop with let results in a reference error, as their scope is limited to the loop itself. Fortunately, the code model can detect most of these issues ahead of time, allowing you to fix them before runtime. Use nullish coalescing and optional chaining operators. Conditional expressions are common in QML when using JavaScript, especially when checking if an object is null or undefined before calling a function or accessing a property. Let's set up an example with some components. First, create a component called owner of type QObject with an integer property. Next, create another component called home, also of type QObject, that uses the owner component. Finally, declare a property for home. Imagine you want to display the number of years owned in a text element if it is available, or new house if it isn't. You also want to show new house if the number of years owned is 0. A typical approach might look like this. Here, you first check if home and home.owner are valid using the ternary operator. Then, you must repeat new house as a fallback for both the years, owned value, and the initial check. Since years owned is defined as a var, it might be undefined, potentially causing it to display new house incorrectly. This approach can be verbose and error-prone. Instead, using nullish coalescing and optional chaining simplifies this greatly. Nullish coalescing, available since Qt 5.15, behaves like a logical OR operator, but checks if the left-hand side is nullish, null or undefined. If it is, the right-hand side is returned, otherwise the left-hand side is. Optional chaining, introduced in Qt 6.2, works with property accesses, function calls, and array subscripts. It evaluates each part of the expression in sequence, stopping if any part is nullish and returning undefined. We can rewrite the text binding using these operators. This version is much shorter and more readable. If home or owner is nullish, the expression stops evaluating and returns undefined, triggering the nullish coalescing operator to display new house. If years owned is undefined, it also defaults to new house, eliminating the need for duplication and making the code more concise. By combining these operators, you create compact, maintainable expressions that minimize logical errors and improve readability. QML supports the inclusion of JavaScript, which can be extremely useful but requires careful usage to maintain performance. By providing type annotations for supported QML types, you allow the QML compiler to convert functions to C++ rather than leaving them as bytecode. This also enhances code auto-completion. We discussed the differences between var and let, demonstrating how their scopes affect behavior. Finally, we explained the benefits of using the nullish coalescing and optional chaining operators. These tools make your code more readable, concise, and less prone to errors, allowing you to write cleaner and more efficient expressions.